Awesome. Thanks everyone for joining, especially late in the evening. Today we are going to be talking about data reliability engineering and why this approach to data quality exists, where it came out of, and we'll end with some actual real world examples of how this is applied today in practice. So do a quick intro. Who am I? I am Egor. I am the co-founder and CTO over here at Bigeye. Bigeye is a data observability platform that helps you monitor your data and make sure that it's fit for use. Before Bigeye, I was over at Uber. I was one of the first people called the data engineer there. My team was responsible for migrating all of analytics for the company from a Postgres replica to a proper data warehouse. We set up Vertica, we wrote a lot of ETL tooling, we migrated everyone's reports, built a consolidated data model, everything you can imagine a data team doing. And I spent about 4.5 years at Uber doing a little bit of everything data. Most of the time was spent building an analytics product for A/B testing. If you're open the Uber app today, you're probably in a couple hundred A/B tests, and any results of those tests were mostly analyzed through this tool. I left Uber in 2019, started Bigeye because one, I had a passion for building data tools, and it seemed like I was going in the wrong direction at Uber. And why data quality specifically? It's because when we went and we talked to people on the ground, people like yourself who are working in the data space, who are dealing with data day to day, the top 3 problems that everyone gave us consistently were, I don't know when my data is correct, which sounds like a data reliability problem. My query doesn't run fast enough, and I was not about to reinvent the data warehouse. And the third one is, I don't know where to find an answer to my data, which is data cataloging, which is in the general data ops space. Would love to talk about data ops at some point as well. So why are we talking about data quality, besides the fact that I got to talk to a handful of data practitioners back in 2019? Well, poor data quality has been a problem forever. This is a well-known problem across the industry. It affects every single organization, no matter how small or how large. This is actually a number from Gartner. They estimate that every year bad data quality costs businesses almost $13 million. And it's hard to conceptualize that. Where's that $13 million coming from? Why are businesses losing money because of bad data quality? So what we've actually broken this down into is a couple of categories that might help you think about why data quality is important. On one hand, let's talk about just risk of bad data quality affecting your revenue stream. So billing errors. You didn't bill a customer, or you billed them multiple times and now you have to do a chargeback, or you didn't charge tax correctly and you didn't notice that in your reporting, and then you have to pay penalties on that. Not detecting fact that people can log in or log out. Someone here was mentioning Kafka. One of the biggest things that Kafka was powering over at Uber is, can drivers and riders get online? And if they couldn't, within a matter of a minute, we would be able to send an alert that something's going wrong. That's data quality affects that, because if those messages aren't being sent, if the pipeline's broken, if the fields are missing, let's say we start dropping driver UUIDs, you're now getting bad alerts. If you're replaying messages historically, you're getting an elevated count. A lot of examples here. Move on to the second, being fined due to bad reporting. Talked a little bit about in the tax example. Moving on from there to compliance. A lot of data is used for analytics purely for the purposes of compliance. So sharing information with a third party, with other third-party vendors and partners that use that information to do something. Having a recommendation engine that actually interacts with shoppers. Reporting state taxes and financial reporting, even going all the way down to your investors if you are a founder. All of this has to do with data and if your data is poor quality, you're not going to do the right things. And finally, what is probably most interesting to the people here is the wasted engineering time. When I was a data engineer, I spent a lot of time on messages in Slack. Well, we used HipChat back then, that were to the effect of, look, I ran this query, it gave me a number. I don't know why it gave me this number. This is weird. Help me understand it. And my time was then spent looking into the underlying tables, looking into the pipelines, figuring out where things came from. And that cycle had to then repeat itself over and over and over again, day in and day out. Instead, what data reliability helps you do is get ahead of that cycle and tell people when something's wrong rather than having them come to you. And so having engineers and data scientists and analysts not waste their time on bad data, maybe go do something else if the data is broken, gets you a lot of benefits from an organizational perspective. I'm sure if you're here, I don't really need to convince you that data reliability is important. So I'm just going to move on to the fun stuff. So how do we get to a place where data reliability is even a phrase? In order to understand this, let's try to look at the way that software engineering evolved and how data engineering evolved about a decade or so later. If you think about software, and you think about creating software, what you usually think about is writing an application, deploying it, having it accessible. If you go back 25, 30 years, you have applications that are literally built on a machine, deployed onto a physical box in a closet. And for you to scale your application, you need to have more physical bare metal boxes in a closet that you then install into a rack. And your database is there, your application's there. If the networking is wrong, people can't access it. And development of software happened at the scale of infrastructure development. How fast can I expand the closet with a bunch of boxes? AWS comes around and creates this whole concept of push button infrastructure. I push a button, I get a server. I push a button, I get a database. I get all my networking. I get all my logging in one place. I can deploy things. I have Lambda functions. Serverless started coming around. So all of a sudden, it became a lot easier to write software and create things for consumers and deploy software and get things going. Developers no longer had to worry about buying servers and putting them in a closet. And so because of that, now there's a lot of different services, and now microservices are starting to become a thing because now it's easy to get these things built, and let's make sure that they're all doing the job that they need to do. So what's the next hurdle that they had to overcome? Well, it's deployment. How do I get these services deployed, talking to each other? This is where you get into things like GitHub and CI/CD and Jenkins and all of this workflow around getting software to work and getting that development process going. And finally, now that you have a ton of different software and applications running somewhere in the cloud, you need to understand whether they're operating like you expect them to. And so you have monitoring observability, Datadog, New Relic, App Dynamics, a lot of these concepts that help you understand tools and concepts such as SRE that help you understand how your systems are performing and whether they're meeting your expectations. So that was the journey in the software space. Do the same thing on the data side. Well, how did data work before? You had a physical box in a closet that ran your Vertica cluster, which is really what I had to deal with a couple of times. I wanted a bigger data warehouse. I had to order the machines, and I had to tell my networking team and my infra team to go and plug them into a rack, and they had to be networked correctly. And if they didn't network them correctly, then they're talking over the public net, and then I bring down the website. May or may not have happened before. Long story short, no fun managing data warehouses. Then you have things like Redshift, Snowflake, and BigQuery coming out and saying, look, swipe a credit card, get a warehouse. Don't worry about networking, boxes, scalability, whatever it is. You just get the bare infrastructure level done for you. Once they got that out, then you had a very easy way to get the infrastructure set up in the same way that you can now get AWS let you get the server stuff set up. So now what's next? Well, I have a warehouse, I need to get data in there. And so now you have tools like Stitch and Fivetran trying to push data into this warehouse in order to make it useful, in order for you to actually be able to do something with it. And before, when you scaled at the rate of physical servers, you could manage those pipelines yourself. We would build Python scripts, everything would be fairly custom. Maybe you have some frameworking around it, but everything is fairly slow moving. I, as a data engineer, knew the pipelines I was working with. I sort of understood the data that was in them, and I knew how to scale them out. Now, Fivetran, I push a button and my HubSpot data and my GitHub data and my transactional system database data is all in my warehouse, and I didn't have to do a single thing. And now the whole world goes nuts and says, well, if we can get all of this data into our warehouse, let's just dump it all in there and get going. So now the data engineers are out of the loop. Data engineers are now being saddled with this notion of, you have a bunch of data and you don't know what it is, and you don't know what the pipelines are doing, and they're just going to auto scale and don't worry about it. And now we're going to go and use that data. And the problem with that is you don't know whether that data is actually good or not. And this is where data reliability comes in. It is the set of tools and practices in order to understand what is the state of your data. Is it fit for use? And can I rely on it in order to do my job, in order to build the data products that I will want to build and provide to the business? So what I just described is a little bit like this, this pyramid, where infrastructure is at the bottom layer, solve problem, very easy to get data infrastructure set up. And what teams then do is they skip straight up to the analytics layer and the machine learning layer, and they're like, cool, we have all of this data in this very scalable warehouse. Let's go and do a bunch of cool stuff, build some reports, build some ML models. This is all very exciting. But what they skip over is all of that operational piece of where is that data coming from? Who owns it? What state is it in? How high quality is it? Is it transformed or not? Is it who has access to it? Infrastructure and ETL tuning. If I'm loading a data set every hour, but I'm only accessing it once a month, do I really need to be loading it once an hour? A lot of this operational overhead that is now being called data ops is a layer that traditionally teams have skipped over. And now that we have scaled past the ability of individual people and teams to manage the scale of their data platform, now we are building this layer of operational data ops and management on top of the existing stack. And what is actually really exciting to me is I'm now talking to data teams that are thinking forward about this and actually building it in this order, where they are starting with their infrastructure and then immediately saying, we know we're going to have 100 pipelines and 2 data engineers in about a week. How do we get ahead of this? And are starting to think about data reliability and cataloging and access control and lineage and all of this information. So let's talk about what data reliability is and what is data reliability engineering. Well, let's start with that same analogy that I just had. There's software and there's data. And software evolved to have the practice of SRE, site reliability engineering. This is famously from Google. Google has an SRE, the SRE book. It's effectively the SRE Bible. Every SRE team looks at that and incorporates the things that make sense. Google obviously has a very large SRE org. They run it slightly differently than everyone else does. Happy to talk about that as well. But for the purposes of this conversation, let's think about the general concept of SRE. And SRE is that set of principles and practices and tools that help software engineering teams build reliable software systems. The SRE team then manages all of that and empowers the organization to be more efficient and not have to worry about the state of the reliability but forces them into these best practices that they have already developed. And if you look at the SRE book has 7 principles of SRE that are considered important to build reliable software systems. So let's go through those. First off, embrace risk. Things are going to break. Just know that they're going to break and know that you will have to deal with it when they do. Second one is setting standards. Have a very clear process for how things get done, and make sure that everyone conforms to those standards. Number 3 is reducing toil. If you have a lot of software systems that you have to manage and keep reliable, you can't be wasting your time and effort on every single one of them. Therefore, you want to minimize the amount of work you have to do to monitor these things and fix these things. Number 4 is monitor everything. So you want to make sure that everything is under observation at all points in time. So because the system is so tightly connected and so tightly coupled that if one thing breaks, that could have massive downstream effects on a million other systems. Number 5, use automation. This is very closely related to reducing toil. The best way to reduce the amount of work that you have to do and the amount of repetitive, redundant work that you have to do is by automating a lot of the common processes. This includes things like detection, but also includes things like resolution. Number 6, controlling your releases. Software, you need to know how software goes out. You need to be testing it. If something goes wrong, it needs to be able to get rolled back. This is a core principle around make sure that you know what is being changed, how it's being changed, and what is affected if that change is bad. And finally, number 7 is favoring simplicity. When you have a lot of systems, the easier it is to use these tools, the easier it is to understand these systems and work with them, the better your life is going to be. And also reduces toil. So these are the principles of SRE. And if you look at them, they aren't specific to software. They are applied to software through SRE, but these are principles that you can apply to almost any job that you have. And if you apply this to the data side of the house, what you have is data reliability engineering. And really what data reliability engineering means is treating data quality like it is an engineering problem. And it's understanding and having these sets of practices and procedures in place that help you build a reliable data ecosystem on top of which all of your data applications can be built. So if we look at the principles, they're all the same. All the same principles apply to data reliability engineering. They're just slightly different. Releases in this case might be ETL changes and schema changes to your tables. Automation might be more around ETL frameworking, and that also goes for reducing toil. Monitoring, this is really where Bigeye fits in very well, is understanding what is the state of the world at all points in time. So a lot of the principles are the same, it's just the implementation of those principles is slightly different. But the key part here is having that set of principles and that foundation of thinking about data quality like it's an engineering problem and solving it like it's an engineering problem. And so we focus a lot on data reliability engineering and talk about what that means for the organization. But at the end of the day, data reliability engineering is just a subset of data operations and what I called data ops before, where data reliability engineering help the types of processes and procedures that you have, creating SLAs for your data, using automation, instrumenting your tables and your ETLs, doing monitoring, alerting, incident management, and resolution workflows, understanding how to have data on calls. This is all part of data reliability engineering, but data ops covers a much broader space. Data ops talks about all of the processes and tools necessary in order for you to operate efficiently as a data team. So everything from tracking costs and doing chargebacks doing access controls, understanding where your data lives, who should access it, who understands it best. Do you have examples? Performance of your queries, making sure that there's no 12-hour queries on your system that are going to time out anyways. I saw a great example of that the other day on LinkedIn, which is hilarious. But having processes and procedures around this is really important to keeping your team as performant as possible. But a key component of that is having the processes around data reliability engineering. Also, as I mentioned, feel free to interrupt me at any point in time. I will just keep going, but chat, Zoom, feel free to raise your hand and I will be happy to take questions or comments along the way. So now that we talked a little bit about DRE itself, let's see some examples of this in the real world and talk about what principles they map to and why these are good practices to begin with. So I think one of the earliest examples of DRE that I ever encountered was Intuit's post about circuit breakers. I have links to these blog posts. I'm more than happy to share these after the fact in chat. So Intuit's circuit breakers had a took a very simple idea that simply said, if data quality fails, if a data quality check fails, if we know that this data isn't correct, stop producing the data immediately and go tell somebody. And you can see in this diagram from the blog post, this is a pretty straightforward concept. There's not a lot of moving pieces. This is extremely simple. Principle number 7. This favors simplicity over any sort of complex system to understand the state of your data and to stop bad data from flowing. So this allows Intuit to trust its data without taking too much time and effort into understanding how to do that. And principle number 5, use automation. Circuit breakers at Intuit were used everywhere. You built a pipeline, you had to say what data quality checks need to pass in order for this pipeline to be correct. If they didn't pass, it automatically killed the pipeline and sent you a message and said, data's wrong, you have to go fix it. And finally, principle number 1, embracing risk. You don't build a system that stops data flow unless you know that your data is going to be wrong. And a lot of people may lie to themselves and say, well, my data is never wrong. We've actually, going back to 2019, when I talked to a bunch of data teams, we've had people tell to our face, we do not have a data quality problem. Our data is always correct. And it's possible to explain to people why that can't be true. But at the end of the day, you have to internalize that notion of things will go wrong. And you have to have these systems in place to understand when they go wrong and be able to react to the fact that they are going wrong. Second example of DRE in practice, Airbnb's Midas. So Midas is the Airbnb's tool in order to certify data sets as gold. I know some teams call these gold data sets standards, or what is it, like the core model, core data sets, whatever you want to call this. But the notion of Midas is we want to tell people that this data set has best practices around it, has tests, all the tests are passing, and we can guarantee its reliability over time. This is a screenshot from the blog post. This is actually in their tool, in their data cataloging tool. And you can see that they even use the word reliability. Midas ensures that the data is reliable. So how does Midas do this? First off, talk about setting standards. Midas says this is what it means for data to be reliable in the organization. It means it needs to have tests. It needs to have best practices around its pipelines. It needs to have a definition that is well known and well understood by the business. Having this set of standards makes it very easy to have a conversation about what is or what isn't reliable data. The second principle this addresses, controlling releases. You can't just willy-nilly certify a data set as Midas certified at Airbnb, you can't just go and click a button and say, yeah, I definitely followed all the best practices here. There are standards that have to be enforced, and Airbnb does a great job of enforcing those standards. And by controlling what gets certified, by controlling the changes to the data sets, and making sure that they are not breaking certification when they, if they would, Airbnb makes sure that any change maintains the reliability of that data. And that is exceptionally important. And finally, I love the favor simplicity principle, because so many tools are just conceptually so easy to grasp. This is a section on a page. You go to a catalog and you say, I want to look at the sales numbers. And you go there and there's just a big block that says, yep, Midas certified. You're all good, ready to roll. There's no other tool you have to go to. The information is pushed to the end user. There is no like interpretation of results. They're already being interpreted for you. There's a lot of work that goes on behind the scenes to create these data sets and get them certified. But for the users of them, the certification is extremely, the process of understanding which tables are certified is extremely simple. And finally, let's talk about UDQ over at Uber. At Uber, everything started prefixed with a U because obviously, so this is Uber data quality. My co-founder, Kyle, was the PM for a number of these services. I worked with a lot of these teams as well. So we have a little bit of familiarity beyond the blog post that I can get into a little as well. But the process at Uber was all of these tools that were integrated together. The point of the universal data quality system is that anywhere that you can touch data, you will have some measure of its correctness. And if it's not correct or reliable, the right people are already being notified. And so if you look at this diagram, the top layer is all the consumption tools. The dashboarding querying tool, the metric tool, all of these consumed information from the data quality system so that that was surfaced at the right time in the right place. There were the rest of the systems below the API line were all well integrated together, where you had tests that were built either programmatically or manually. They all got run. If they failed, they would get alerted. The alerts would go to the right place. They'd notify the right tools and the right people. An incident would get created for you. All of this would happen automatically behind the scenes. You didn't have to interpret a result, look at a number and say, oh, this is definitely bad. Let me go create an outage. This was all handled behind the scenes in UDQ. So let's talk about some of the principles here. Embracing risk. Again, everything had the sense of this at any point in time could break. So let's just make sure we are surfacing that information as soon as possible. This is why all the consumption tools use the outputs from UDQ, is because as a user, you want to know when things break, and this is how you get there. The system reduced toil. It reduced toil by integrating all of the key components of data quality and reliability into one unified interface. Once I create a test and say that if this fails, go tell me about it, and it's going to affect this particular table, the rest of the system just did the job for you. The test got run, the alerts would get generated, sent to the right place, surfaced to the right people, incidents would get created, metrics would get reported. All of this was handled for you. You didn't have to do anything. And reducing the toil on the engineer made it so that the engineer can focus on the things that are important, which is defining what it means to be high quality and responding to the alerts and not having to worry about anything in the middle. And finally, using automation. I just mentioned that everything was automated. The information was surfaced automatically in the tools that you're already using. All the processes were automated behind the scenes, and that made this whole process a lot easier than it would have been otherwise. And that's it for my slides. I am more than happy to take questions about anything I covered here, any other data topics that you would like to know about. I would also like to plug Dracon now as well. If you liked what you saw here, this is a bit of a preview of the kinds of things we would talk about Dracon at Dracon. So please go register dracon.org. I will also post that in the chat.
Awesome, thanks. What questions do you have for Egor? Anyone?
Doesn't have to be data reliability. I can also talk about anything else data related.
I do have a question. At what stage should a company start considering observability in their pipeline? Is there a maturity level? Is there a tools they have to have, or what do you think?
It's the tools you have to have, going back to that sort of like layering slide. If you don't have a data warehouse and you don't have an automated ETL framework system that pushes data into your warehouse, then there's nothing to observe really. Like maybe you have one-off scripts that run and it's fine. It's at the scale that you can still manage it yourself. Once you get into a world of, I have Snowflake and I have Fivetran pushing data into it, and I'm now writing ETLs on top of it, I'm using that data for analytics. Once you start using that data, and there's a lot of it for some business use case, that's when observability really comes into play, and that feeds into your data reliability story altogether.
Yeah, I really like let me turn on my video. Hey. Yes, I really like the part of your presentation where you talked about the journey that software engineering had to go through, how we basically learned how to deliver our software as a product. And now, we're going through the same journey, trying to deliver data as a product, right? We build testing infrastructures, we use the same tooling, we use release deployment process, CI/CD around data, just to deliver that data as a product. And in the last few years, there were discussions about different ways to organize your data, like data mesh versus data fabric, for example. Do you see, and I'm sure you're familiar with the companies using different organizations, do you see any DRE specific issues that you would attribute to one or the other? Would you recommend one over the other in which circumstances?
That's a great question. The way that I look at data is data. You're going to have to measure its reliability regardless of the frameworks that you are using in order to deliver it and in order to work with it. So if you have data, you probably have reliability problems. The only thing that data mesh really does is it now distributes that problem for you. So now you have a lot of teams worrying about this problem rather than one team worrying about it. From the perspective of data reliability, none of the approaches to managing your data platform really make a big difference.
I'm sorry. Let me ask you this: when you switch to data mesh, now you have producer or the domain expert team owning that data and responsible for the quality of that data. Where you have a data fabric, data platform team really is responsible for the quality.
Yes. The thing that I was trying to say is quality is going to be a problem regardless, and you're just changing who owns the problem space. I think the most important thing for data mesh, though, is you are now scaling out because you're scaling out the ownership, you need to have a really good tool chain in order to be able to do that. When you have a centralized data platform team, they can build their own tools and they know how their systems work and they can make changes cohesively as a unit. When you have a data mesh, it's like it's sort of like a free-for-all. And that's where you need a central team. And this is what I would really call a data platform team, is the team that empowers data teams across the rest of the organization to do their best job. And this is where you need data observability tooling like Bigeye. This is where you need data cataloging, so everyone has a standard for where to find data. This is where you need tool like ETL frameworks so that everyone kind of has a consistent way of thinking about building their data sets. Data mesh just makes this a distributed problem, but the problem still exists.
Have you seen any successful implementations of data mesh?
Ooh,
Any, because it seems it's such a big problem, for example, for us to implement this, because really domain experts don't really want to own their own data.
I think a good place to ask would be on our Friday show with Zemek Degani.
At some point, I want to do a panel with Zemek and have a debate about this. I have opinions about data mesh. I think it is a great concept in principle. Conceptually distributing the ownership of the data to the teams that understand the data best makes a lot of sense. Like just conceptually, they know how it evolves. They can control the evolution of it. They can control the definition of it. They can test the quality of it because they know what it means. They can own the definitions. They can own the standardization of it. Conceptually, data mesh makes a lot of sense. My biggest problem with data mesh, like you mentioned, is the complexity of implementation. Teams just don't care. Engineers don't care about data. Data is an afterthought to engineers. Their job is to write software and meet the deadlines and move on to the next project. And if you don't have a strong, almost like top-down force pressing on these teams and saying, you have to do this. There are KPIs that we will measure you on. And if you are not providing reliable data and standardized data from your team, you are failing as a team. Unless that exists in our organization, I can't see why anybody would actually be incentivized to implement data mesh when they have competing priorities in the
this brings up a good question, Egor, because you were I think fairly early at Uber, and Uber's I think widely recognized as being a data first company, right? And so do you think that data mesh could have been implemented or achieved at a place like Uber?
No.
Okay.
It could not have, and I'll tell you why. So the way that data, I'll give you a little bit of background on how data worked at Uber, and then I'll tell you why we landed on that model and
awesome.
How we got there. So when I joined, I was part of what was called the data warehouse team. Realistically, we were the data team. There was no more data. Like everyone was, people queried and had dashboards and there were analysts, but there was no actual like data team providing the service of having data as a product. So that was the responsibility of my team. As the time went on, there was a warehouse team. Hadoop became a bigger thing, and a data lake became a thing. You had the data modeling and engineering team that then had sort of an embedded model with other teams. And as the organization grew, you had smaller data teams that tried to create their own sort of like data meshy domains. So Uber Eats was a great example of this. Uber Freight, once that started coming out, was a good example of this, where this is highly domain specific data that they had to think about and had to work with and create pipelines for. The problem with that is that same problem of standardization. Eats data was a mess half of the time. And the reason that it was a mess half the time is because there wasn't anybody telling them your data has to be good. And in general, there was no organizational pressure for these teams to create good data practices and pipelines. The data would get fixed when a consumer would complain about it, not because it had to be. You would have models that differed completely. Like there was at some point there was fact trip and fact eats trip, and it overlapped by about 80%. And then everything else was just completely off the wall. And the way that we solved it at Uber is the data engineering and modeling team embedded people with Eats and said, you will follow our best practices. We will tell you how to do this. We'll tell you how to build better pipelines. We'll tell you how to test them. We will fold your information into the core models and create core models for you and help you think about creating core models. But that hub and spoke model of that data engineering team was required as that incentive, as that we will help you do the right thing. The teams weren't incentivized to do the right thing. And I, in general, have a fairly unpleasant experience working with engineering teams and product teams around data. In general, they think of data as an afterthought because it is typically data is an exhaust for them. The fact that a trip happened and the fact that we recorded it, all they need to know is that, did we charge the driver and the rider, and did we record it durably? And then it's fired off into a Kafka topic and lost forever. We don't care about it. Once we fired it off to Kafka, nothing matters to us anymore. We did all the fields get populated? Did the model change? Did we update a JSON schema, which happened all the time? That doesn't matter. Someone else is going to handle that. That's not my problem. And until the business and the organization can make it this product team's problem, it never will be. And this is why data mesh cannot work at a large enough organization, is because nobody cares and there's nobody to make them care.
It goes back to, what is it, Conway's Law?
Yeah.
So yeah, it's interesting. Yeah, I mean, I think data mesh definitely has the potential to be, I mean, it's one of the biggest new ideas. I wouldn't say necessarily new in the sense, it reminds me a lot of the impact microservices had back in the day, but it's, if it could work, it would be awesome. But of course, you got humans and small details like that.
I think conceptually it is great. I think the only way to make data mesh work is by having a very strong tool chain around it and then forcing everyone into it. Like, you have to say, this is how we do data reliability. We use Bigeye. You have to have an account. You have to create your SLAs for your team, and you will be held accountable for them. This is how we do pipeline management. This is our framework for pipelines. We use dbt. Here are the built-in macros that everybody uses, and this is the processes that everyone uses. And we use Airflow, and here's your operator that you have to use, and everything goes through the same tool chain. Then you can start enforcing these standards, and then you can let the teams worry more about their domain-specific things. But if the teams are going to have to figure it out for themselves, that's going to be a tough sell.
It's got a question in the chat here. Switching gears, back to Bigeye. Does Bigeye also enable data discovery cataloging along with data quality checks?
So Bigeye, it allows for discovery in a weird sense. So here's what I mean by this. Bigeye allows you to create SLAs around your data sets and understand how they're performing. You can then see what data sets exist, which data sets are problematic. There is a catalog part of Bigeye, but that is mostly for navigating to the things that you care about and understanding what is failing and what is not. Now, it is a natural extension, I feel, to have a stronger discovery and cataloging process, because data quality and data cataloging are very closely related. If you have data quality checks and you say, my sales table is broken and I need to pull my sales number for next week, what's next? Bigeye does a great job of telling you this is why it's happening and why it's broken and what you can do to fix it and what it's affecting. But a lot of times the second question the end user has is, well, where should I look next? What other table should I use? And that is a natural adjacency for Bigeye. We don't have that today, but it's definitely something that we have thought about a lot.
Thanks. I mean, I want to get your perspective on this. There are a lot of companies in the observability space. I think there's almost as many atoms in the universe as there are possibly like observability companies right now. I mean, how is it? What's it like differentiating in a fairly crowded market right now?
Yeah, I think there are 23 that we're tracking.
Okay,
but Yeah, I agree with you. Data observability is the hotness right now. It differentiating is interesting because every single company is focusing on something different. It's actually less about how are we differentiating against other companies, and it's what is Bigeye really good at, and is anyone else good at that? And interestingly enough, the answer is often no. Every single data observability company, if you like read through the docs and look at their product demos, everyone is good at something different, which is interesting because you'd think like, okay, well, data observability, it's like, it's one concept. How can it be so different? But let me give you a couple of examples of this. So what we at Bigeye are really good at is giving you a very strong platform to build your observability observability story on top of. We are very extensible. We can create metrics out of practically anything at this point. They will run, they will alert you. We can create SLAs. We can group these concepts for you. We'll create issues and you can track your issues through Bigeye. We help you along that process of finding and dealing with data issues very well and very efficiently. And we are also very engineering friendly. I was a data engineer. My co-founder Kyle, he was a data scientist and then a PM on data teams. We want to be engineering first. We want to be as extensible as possible. We have APIs for everything. We have customers that don't even log into the UI. They just use our APIs. They create all their monitoring. They manage all their alerts. Almost everything goes through the API. And we are really proud of being able to support use cases like that, where teams just say, we know what we want to build, and you're giving me a really strong platform to build it on top of, and now we will integrate it into the rest of our ecosystem. That is really where I see our differentiation. And the second part of that is because it is, the reason I call it a platform, and I know the platform is a very like hand-wavy term that everyone likes to use to raise more money, but the real reason that I call this a platform is that all of the pieces of it work well together. So at Bigeye, we have the notion of metrics, and you collect metrics about your data to understand the state of it. So basic metric, row counts. How many records are you loading into a table every day? If you're loading right around 10,000 rows, give or take, every day, and then yesterday you loaded 5,000 rows, sounds like a problem. So your metric is that the computation of that, how many rows are you loading per day? And we have a lot of metrics, but that metric then creates it can be part of an SLA that says, this is my expectations of my data. And if anything is broken, then this data product is broken. Either that's a pipeline, a table, a dashboard, whatever that is. That is then tracked through issues. That same metric can be then like you have history of those metric alerts in the issues. Metrics have history of the issues that they generated. Everything is interconnected with itself. Now that we're starting to build other functionality such as deltas, which is comparing two tables to how they're different, that's piggybacks on top of metrics. We pretty much just auto-generate a bunch of metrics for you, compare them, and then give you some output. Every piece kind of works well together. And because of that, we are very extensible and sort of like the sky is the limit at that point in terms of what we can build and what a lot of our customers are building on top of us.
Yeah, that's super cool.
If you look at a lot of other data observability tools, they focus on different things. Some of them focus on pipeline observability. Some of them live in your pipeline and say, if your pipeline broke, we can start capturing signals like that. Great Expectations, another good example of this. Great Expectations is purely code-based. I mean, I think they have a UI now, but it's mostly fold this into your Spark job. Very engineering, very pipeline-oriented, very focused on that use case. Bigeye doesn't have a Spark SDK. We don't have anything that we can shove into code for you. So that's really their differentiation. If you look at Monte Carlo, Monte Carlo has a great lineage interface, but and that's what they're good at. And then if you look at Datafold, they invented data diffs. Deltas is really a direct competitor at that point of Datafold's data diffs, but they differentiated that way. So everyone is focusing on a different subset of the problem. And I think at some point, I think the next part of this question is, well, how does this all end? I think there will be sort of a day of reckoning and a great consolidation in the data observability space. I don't think we're there yet. I think there's a lot of uncharted territory yet still, especially in terms of the kind of product offering that you can make and the abstractions that you can build on top of observability that are useful to users. But it's an exciting space, and I think it's only going to get more exciting, but I do wish it was a little less crowded.
Well, I mean, you're doing something right.
We're on to something.
That's so cool. Who else has questions? Actually, there's one here in the chat here. Is there a way to track data sets in the context of pipelines / jobs, etc.? Delta feature is very interesting.
Yeah. So yes, there is. So there are deltas is being able to compare tables to each other. There's really two major use cases that our customers use this for. One is migrations. I feel like data migrations are an ever-present phenomenon in this space. Everyone's migrating from one warehouse to another at some point in time. And a lot we have customers that use deltas to say, I have a SQL Server database and I'm migrating to Snowflake, and I need to make sure that my migration is going smoothly so I can trust the results from Snowflake. And they use deltas to say, do the two data sets look the same? And if they don't, where do they not look the same? The second one is, like you mentioned, Sahu, the second one is the pipeline monitoring, which is, I have a DBT job. I just made a change to my DBT model. I created a PR. What's different? And we have customers that are building, that are using deltas as that integration piece of, I'm going to go create a new copy of my table from my PR. I'm going to take my production table and I'm going to compare the two and say what has changed. And if anything has changed that you don't expect, you can then catch that before that model goes out in production. And so it is definitely a very interesting feature. I'd love to tell you more about it. If you can email me, Egor@bigeye.com, and I'd be happy to talk more about deltas.
Alec asks, this is for the viewers out there who'll be watching this. Well, questions galore coming in. Okay, so Alec asks, does Bigeye track data lineage? If so, how do you do that across various ETL and data stores?
So I guess I will give this group a slight preview. We do not track data lineage today publicly, but we are starting a beta program for lineage within a warehouse and as well as outside of it. So going up and downstream. So given that this is recorded, I'm not going to talk too much more, but Alec, again, email me, Egor@bigeye.com, find me on LinkedIn. I will be happy to tell you more in a non-recorded session.
Perfect. Murillo asks, how does data reliability differ from data quality conceptually? To him, they seem pretty much the same thing.
Yep. So I think data quality is a very broad term, and a lot of people use the term data quality to mean a lot of different things. In my mind, data quality is a point-in-time measure. And data quality is a measure of the state of a specific table or product or data pipeline, where you can say, this is the quality of my data because this is how I've defined it. The quality scores actually, this is why I don't like data quality scores, is because you're simplifying a very large number of things that could go wrong and a large number of concepts about the data into one numeric that you're trying to say this is all it is. Data reliability is about how fit is this data for my use case. So for example, let's say your definition of data quality for something is, this data set needs to update. Going back to my example earlier, this data set needs to update hourly. That is a data quality rule that you write. And if the data set doesn't update hourly, then you raise an alert. Or nulls. This column can never be null. Very common data quality rule. This column is never null. Data reliability says, okay, well, what happens if it is null? Is anything affected? Who should take care of that? Who needs to be notified about that? Is anyone even using this column? Like, is this actually a problem? How big of a problem is this? And data reliability helps you create the processes and procedures in order to address that. Data quality is the signal into it, that point in time signal of something is wrong. Data reliability is the set of procedures around it in order to understand what do you need to do and how should you react to the problem.
Thanks. What other questions? I've got one. So yesterday I was chatting with a company and they showed me, so they were like role-based access control. They're showing me templates for compliance of like GDPR, CCPA, and so forth, which is pretty sick. Actually, it's pretty cool. But it's cool that, you know, you can set the rules for compliance, but then how do you observe that compliance is being tracked? Is it something that Bigeye currently does, or do you see that on the horizon for observability as well? Tracking like deviations in data compliance.
That's interesting. It depends on what you mean by data compliance.
Well,
right?
I mean, are you breaking the law or not? So,
yeah. Well, a lot of data laws are actually very iffy. What, like, for here's a great example. What is PII? PII, like by law, it's something that can identify a single individual.
Mm-hmm.
A last name is not PII. An email address is, but a last name and a zip code is PII because that can identify an individual. So the compliance part gets a little bit tricky. Yeah. Now, can data observability help in this? Yes, you can create. So especially going back to that, what I said about Bigeye, you can create the the kinds of rules that you need in order to track changes in some properties, right? Now, do I see data observability going into the compliance space? Probably not. It's probably more of a supporting role where it helps you understand the state of your data. And some of those signals from the state of your data are going to go towards, hey, this may or may not be in compliance. And then going back to the data reliability piece and data reliability engineering, what then? If this alert fires, who needs to know about? Who needs to know about it? How do I react to it? Is this urgent or not? Is anyone even looking at this data? Maybe no one's looking at this data, and so it can be out of compliance for a little bit while we go and fix it, versus this is the core table and we need to bring it down immediately. So that's where data reliability comes in. Data observability feeds the signals into that, but I find it hard to believe that data observability and compliance would blend.
Yeah, thank you. What are the questions? Do you want to give a shout out for anything?
Give a shout out to about Dracon. I also want to give another shout out to, I think, DBT. Everyone here probably knows DBT. Everyone here, I bet, loves DBT. We use DBT internally at Bigeye. We've been doing a lot of work integrating with DBT processes, like I mentioned, the PRs and deltas. We have done a lot of work in that. I think that DBT is building all of the right tools and frameworks to think about ETL, and they have done a great job of creating the sorts of standards that we actually should have as a data community. So I love DBT. I love the people that I met from DBT. So massive shout out to them.
Yeah, for sure. Doing great things. Well, awesome. I think that wraps it up then. Thanks, Egor. So a round of applause or reaction emojis, whichever.
Yeah.
So, yeah, awesome. So next month, I think we have a presentation lined up. It may involve graph databases. Don't quote me on that yet. So still lining it up. But yeah, we got a lot of things in store. I think Igor's actually going to be on a Monday morning data chat. One of these.
Yes, I should shout that out. It's actually next week. That's a good point.
Wait,
so,
is it next week?
Oh no, not the Monday. Sorry,
It's
next week I have a Wednesday data stack show.
Yeah,
it's in 2. I think ours is in 2 or 3 weeks.
2 or 3 weeks, yeah, something like that. Yeah,
2 or 3 weeks. But
so it'll be fun. Yeah,
next
data
Wednesday
stack show is good.
So if you don't listen to it, the data stack show is Rudder Stacks podcast. We are doing a live data observability panel with myself, with Kevin from Metaplane, CEO of Metaplane.
Nice.
And Manu, CEO of LightUp. So we are just getting a bunch of data observability founders in a room, and we're going to talk about data observability. So you should definitely dial into that one.
That's cool. I've been on the Rudder Stack podcast before. That's a great show. So yeah, definitely tune into that. Super smart panel. So like that's awesome. So cool. I'm gonna stop the recording and we can catch up. So thank you and ending.